In Chapter 5, we're going to look at polynomials in general. If you remember in Chapter 4, we dealt with quadratics, where the highest power was 2. Now in Chapter 5, we can have the highest power being 3, 4, 5, or keep going when we talk about polynomials in general. So in Section 1, we're going to look at being good at our exponent rules. That's what we're going to start with in the first lesson, is looking at exponent rules. And then in the second half of this, we'll look at adding, subtracting, and multiplying polynomials. The very first thing that we're going to do is look at some of our exponent rules, just to get an idea as to where these come from. We're going to kind of look at it through this scenario in here. So 2 to the 4th we know is really the same thing as 16. 2 to the 3rd we know is 8. 2 squared we know is 4. 2 to the 1st we know is 2. This first number 5 here, this is where we kind of get our first rule from. Anything to the 0 power is 1. If I look at my relationship going from 16 to 8, I'm dividing by 2. 8 divided by 2 gets me 4. 4 divided by 2 gets me 2. And then 2 divided by 2 gets me 1. So anything to the 0 power is going to be 1. We can keep going with this same pattern. 2 to the negative first is really going to be 1/2 if I divide by 2. This kind of gets us another rule. A negative exponent is going to flip locations. So if 2 to the negative second is in the numerator, well, then it's going to flip and go to the denominator. So 1 over 2 squared, which is really the same thing as 1/4. Same thing for this one. It would be 1 over 2 cubed, which is really the same thing as 1/8. And the last one, also same, 1 over 2 to the 4th, which is the same thing as 1 over 16. Now, if a number does start negative in the denominator, say I have 1 over, 3 to the negative second, then it would be the same thing as 3 squared. So really, a negative exponent is just going to flip its location. It's either going to go from the numerator to the denominator or the denominator to the numerator. A few more exponent rules that we have. 1 and 2 are pretty much identical. This first one is saying 2 squared times 2 to the 3rd. Well, 2 squared is the same thing as 2 times 2. And 2 to the 3rd is the same thing as 2 times 2 times 2. If I add up all these 2's, that means I have 5 of them, so it's really the same thing as 2 to the 5th. If I go back to the original, to get 2 to the 5th, I would just add my exponents. If I have like bases, we add exponents. Same thing with this one. 3 squared times 3 to the 4th is the same thing as 3 to the 6th power. Number 3 here, this is where we're going to use a little subtraction. You can also think of it as 3 to the 3rd over 3 to the 5th is the same thing as 3 times 3 times 3 over 3 times 3 times 3 times 3 times 3. And then I can start canceling some of these 3's out, which gets us 1 over 3 squared. Or if I look at my original, I can subtract these. 5 minus 3 is the same thing as 2. And since I started with more on the bottom, I should finish with more in the bottom. Likewise for number 4, 8 to the 5th over 8 to the 3rd. Well, that should be 8 squared, because 5 minus 3 again is 2. And I started with more in the numerator. Number 5, 9 squared to the 3rd power is really the same thing as 9 squared times 9 squared times 9 squared, which really is 9 to the 6th power. If I go back to the original, I would just multiply my exponents together. It's the power of power. 2 times 3 would get me 6. Down here at the bottom, 5 squared to the 4th. Well, that's the same thing as 5 to the 8th power. Number 7, people sometimes forget that these exponents are also going to go to the numbers as well. So really, this is the same thing as 4 to the 3rd times x to the 6th. This last one is where we can put it all together now. So I'm going to start by kind of distributing the 3 in. So I have 5 to the 3rd times x to the 6th over 2 to the 3rd, x to the 9th, and y to the 12th. We can continue simplifying. 5 to the 3rd is the same thing as 125, x to the 6th over 8, x to the 9th, y to the 12th. Last thing I see is that I have 6 x's on top and 9 on the bottom, so I can subtract 9 minus 6 to get me 3. And since I had more on the bottom, I should have more on the bottom to finish. So 125 over 8x cubed y to the 12th. I'll also look to see if I can simplify 125 and 8, and I know that I can't. You'll want to check that to see if you can reduce your fraction. And since you can't, this is your final answer.